So second to last section we're going to look at this week is 1.2. It's on using the graphing calculator and finding what we call a complete graph. Okay, so we'll talk more about what it means to have a complete graph. Basically, we're gonna start by talking about very general an approach that you can take to solving problems. Not necessarily even a math problem, but just kind of any kind of problem you might come across. And the first step that you need to kind of think through in your head is you need to read through the problem that you're being given and break down the information in the problem into like two categories. First of all, what is the information that they're giving you that you can use to solve the problem? And then what is it that they're asking me to figure out? What is the information that they want me to write down for the answer? Okay, so that's the first step, kind of breaking down the information. What do you have to work with? What do you know? And then what is it that you have to figure out? Now, in math, there's several ways to solve problems. So the next step is to kind of figure out what approach are we going to use to solve the problem. Now, let's say I gave you a problem like you've got a swimming pool that's rectangular. It has dimensions of, bless you, 30 feet by 50 feet, so it's a rectangular swimming pool. You're going to put a sidewalk around the swimming pool that has a certain width, and I want to figure out like how much concrete you're going to need to make the sidewalk. So there's a lot of words there, a lot of words, a lot of numbers. What do you think would make it easier for almost any word problem to kind of see what's going on in the problem, rather than just reading all the sentences? You could take it all and turn it into a,
Like a chart?
Yeah, a chart, or making like a picture of everything. So drawing a picture is something we'll do quite a bit. When we get to trig, we're going to talk about right triangles, and we'll use the terms opposite and adjacent. So it's very helpful if we draw it that we can see that. Okay, opposite is over here, adjacent's over here. It just makes it easier to visualize. Okay, another approach to solving problems sometimes is to make a list. So one example that would be relatively practical to make a list is if I gave you the letters, let's say, letters A, B, and C, and I asked you what are all the different ways you can take the letters A, B, and C and rearrange them. So you could have like ABC, ACB, BAC, BCA, CAB, CBA. So I did that in a very systematic way. I did it in alphabetical order, so I wouldn't miss any. Now, there was only 6, so it wasn't that bad. But what if I said to you, I want to know how many ways you can arrange every letter in the alphabet, all the letters, but you can only use each letter one time. What would happen to your list if you tried to write all those down? Yeah, list. It would be a very long list. So sometimes a list isn't practical. If your list is going to have even 100 things in it, but that's not really practical to sit there and write 100 things down. Never mind if it had billions of things, like the problem I just said probably would. All right. So a list isn't always practical. Making and solving an equation. That's usually going to come up a lot with making a picture at the same time. So like if you had a problem where you had a triangle, and I told you one side was 5, the other side was 7, and I wanted you to solve for x. Okay, there's your picture. There's a relatively well-known formula you can use to find the third side in a right triangle, as long as you know 2. Does anybody know the formula that I'm thinking of? Okay.
A squared plus b squared equals c squared.
Yep, and what is that?
Pythagorean theorem.
Yeah, the Pythagorean theorem. So sometimes when you're doing a word problem, the formula or the equation you need to use is a formula that's very well known, okay? And you can use something that's already made for you. Sometimes when you're solving a word problem, you have to make your own formula. Okay, there is no formula that's already been made because the word problem is a very specific problem to that situation. Okay, and that's the one we're going to start out with. We're going to do a word problem that there's no general formula that you can use. You got to make your own from scratch. Okay, it's all different ways that you can think about solving a problem. And then the last step is to actually, once you've decided on the method, now you want to actually carry out that method. So if you picked making and setting up an equation as your method that you're going to use, now you've got to carry that out. How are you going to solve that equation? Is it a quadratic? If it is, are we going to use quadratic formula? We're going to factor it. We're going to complete the square. We have to carry out whatever method we decide. Any questions on those general kind of guidelines for solving problems? All right, so now let's look at a question and see if we can apply those methods. So first of all, this problem is telling you which method they want you to use. At least for now. They say write an equation. And our equation has to model what's happening in this problem. So we've got a company that charges $15 to rent a car, and then they charge 20 cents for every mile you drive. So we want to write an equation that represents that situation. Okay, so first thing, we are going to have two different variables in this problem. Anybody think they know what one of my variables is going to represent? Yes, go ahead.
How much it is to rent the car?
Yeah, how much the total cost once you rent the car. And what's the other variable that you're going to have that's basically going to control what the cost is? Yep, Anthony?
How much you pay for every mile?
That's a constant. It's always 20 cents per mile.
The miles?
The miles itself, yes. That's a variable. We don't know how many miles the car is going to be driven. But the cost per mile is set. It's fixed. So we're going to let y be our total cost and x be the number of miles we drive the car. Another name for the y variable is the dependent. Based on that, anybody think they remember the other name for the x variable? Yeah?
The independent?
Independent, yep. And those aren't interchangeable. You cannot really switch those. And the way that I figure out which one is dependent and independent is I kind of say a sentence like in my head and see which one makes sense. Is the total cost dependent on how many miles I drive? Or is how many miles I drive dependent on the cost? The second one doesn't make sense. Number of miles that you drive is not dependent on the cost. When you rent a car, like if you're renting it for like a trip or you're going somewhere, you have to drive the number of miles you're going to drive. Like the number of miles is what's in control. Okay? That is the independent variable. The cost that you pay depends on the number of miles. So cost is dependent on miles. That's how I figure out cost is the dependent. All right, so now we got our two variables. Let's write an equation. So it's going to start out y equals. And anybody think they could give me a formula that I could put on the right side of that equal sign that's going to represent this situation? Yep, Ariel?
15 plus 0.2x.
Yeah, I'm just going to write it 0.2x plus 15, which she says perfectly fine. Does anybody know why I put it in that order? that is something special. Martin?
Y equals mx plus b.
Yeah, it's like a y equals mx plus b equation, standard slope intercept. They didn't say to do that. Just have it. Okay. And there you go. So there's your equation. Y equals 0.2x plus 15. Any question on how we got that equation? Okay. So what we want to do now is use the model, that means use the equation, to find the cost when you drive 50 miles. Okay, so in order to find the cost to drive 50 miles, what would you do with the 50 and the formula we have up above? Yeah.
You plug it in the x.
Yeah, you're going to take the 50 and you're going to fill it in for x. So we get y equals 0.2 times 50 plus 15. Okay, we'll type it in on the calculator. If you are on a screen that you don't want to be on, and you want to get back to the screen where you can type in numbers, if you press second and then the mode button, that's quit. It'll get you out of whatever thing you're in. So second quit is one way to get back to that screen. All right, I'm going to press clear, just get rid of everything that's there. 0.2 times 50 is 10, plus 15 is 25. And what is that? $25, right? Not miles. That's $25 to rent the car. Okay, so that's the cost for $25, 50 miles. Now, for 100 miles, can I just say it's double the miles, so just double the cost? It's going to cost $50. No, why doesn't that work? Yeah, Matt?
Because you would also be doubling the 15 that you already put in for the car.
Yeah, we don't, that's like the down payment, like the 15. We don't double that. We can double the mileage part of the fee, but not the $15 part of the fee. So now we're going to do 0.2 times 100 plus 15. What's 0.2 times 100?
That's 20.
20. And then plus 15 is going to give me?
35.
$35. Any questions on how we got that? Yes.
Can you use the bathroom real quick?
Yeah, just sign out. All right, so both of those examples that we just did, they weren't algebra. They were more arithmetic. The variable that you wanted to solve for was y, the cost, and that variable was already by itself. Okay, so we just had to do arithmetic to get the answer. That equation, 0.2x plus 15, okay, that is called the, or 0.20x, same thing. That's called the algebraic representation of our problem. Okay, if somebody were to walk in here right now and look at that equation on the board, because it's purely an algebraic representation, they would have no idea that this is about renting a car that costs 20 cents per mile and $15 upfront. The algebraic representation kind of extracts all those details about the word problem and reduces it down to just a pure mathematical equation. The other thing that somebody wouldn't know walking in here is what you could plug in for x. Because in theory, you can take any number in math and multiply it by 0.2 and then add 15. But we know x is a number of miles, and the number of miles can't be certain kinds of numbers. Like, what wouldn't make sense for a number of miles? Yeah. Yeah, you wouldn't have negatives. So mathematically, yes, you can plug in a negative for x, but in the context of the word problem, no, that doesn't make sense. Okay. So if you are asked to find an algebraic representation for a problem, it means to write an equation. I think there's a question in the homework that says, if I apply it to the one we just did, it says generalize the pattern in the problem. Write down the cost of the car in terms of the number of miles you drive. All that that's saying is write an equation for the problem. So sometimes we got to interpret a little bit how the question is worded, just the way the book writes it. All right, now let's try this. Using that same rent-a-car example, suppose that Sarah was charged $50 to rent the car. How many miles did she drive? Okay, what's different this time about the question that's being asked? This isn't really the same thing we did before. Aiden?
It's trying to figure out how many miles instead of the total cost.
Right, so what variable are we solving for?
For X.
Right, we're solving for x, and the x is not by itself. So now we do need to do algebra and get the x alone. Okay. So since we're solving for x, that means we're going to plug the 50 in for what letter? Yep. We're going to plug it in for y. Okay. So we got 50 equals 0.20x plus 15. I meant to write that down here. So we're going to solve this equation I said using algebra. 50 equals 0.2x plus 15. Okay, what's your first step to getting x by itself? Yeah, there you go.
Subtract 15 from both sides.
Okay, so subtract 15 on both sides. And 50 minus 15 leaves me with 35. Again, what do you write 0.2x or 0.20x? In math, that's the same number. In science, you might get into like significant figures, but we don't really do that in this class. Okay, so 35 equals 0.20x. Now I got to get rid of that 0.20x. So what would I do on both sides? Martin?
Divide by 0.20.
Yep, divide each side by 0.20. And when you divide by a number less than 1, like 0.2, what actually happens to the thing you started with? Yeah?
It gets multiplied.
Yeah, it's really going to get multiplied. So it's going to end up getting bigger. So 35 divided by 0.2 is 175. 35 divided by 0.2 is 175. All right, so that is 175. And that's 175 miles. Yes. All right, and that's how you solve it algebraically. We used what's called inverse operations. We had a plus 15, so we did the inverse. We did a minus 15. We had a times 0.20, so we did a divide by 0.20. Those are inverses. Okay. Another way we can solve it is on the calculator. So let's take a look at how to do it that way. Okay, to do it on the calculator, I'm going to go back to what I had at that step. It was the initial equation that I wrote down. All right. And what I'm going to do is, once it's on, I'm going to go in the upper left, press y equals. If there is anything in there, we can just go ahead and clear that out. And now we're going to type in two things. Okay, I think you can type up to 10 equations. It goes all the way to y0. You can type 10 things in at a time. We need to type 2. We're going to start with this. And we're going to type what's in that blue box in Y1. And we're going to type, actually I'll use a different color. We're going to type what's in that purple box. We're going to put that in Y2. Okay, so on the line that says Y1, put in 50. And then if you hit enter, it'll move you to the next line, or you can press the down arrow. Either way. Now Y2, type what's in the purple box. Point, kind of cut my decimal point off a little bit. 0.20x plus 15. Now we're going to solve it graphically. So we're going to hit graph, and we're going to look on the screen where the picture in Y1 is equal to the picture we drew in Y2. What do you think that really means? If we're going to look where two pictures are equal on the screen. We're really going to be looking for where these pictures do what? Yeah.
Intersect.
Yeah, we're going to be looking for where these pictures intersect. Okay, we're going to be looking for where they cross. So type that in. We're going to press zoom. And what did I say the window that we start with is usually? Yep.
Standard.
Yeah, we'll do the standard window. When we get to trig, we'll do zoom 7 a lot. But I would say zoom 6 and 7 are what we use the most often. As long as the yellow circle's spinning in the upper right, it's doing something, it's thinking. And it's done. Okay, so why don't I see anything? Where's my graph? Yeah.
It's not on the graph, it's actually higher.
Yeah, it's not on the window that's the standard window. It's outside the standard window. So I've got 4 numbers I can adjust. These x min max, y min and max. Which one do you think I need to adjust? Might be a couple. But what do you think one of them is I need to adjust? Yeah.
The Y.
Yeah, which one?
Max.
The max, yeah. When you set y equal to a number, like y equals 50, that's a horizontal line at that number. My window is going up to 10. So am I going to see a line that's at 50? No. So I want to set my y max higher. Okay, so it's not right on the edge of the screen. I would probably do like, I don't know, 65 or 70. If you set it to 50, then the line is going to be right on the edge of the screen, and it could make some things hard to see. So we're going to get a little extra. Now when we hit graph, we see a horizontal line at 50. And there's my line with a slope of 0.2 and a y-intercept of plus 15. All right, and what am I looking for again?
Where they intersect.
Where they intersect. With the standard window, x max is only at 10. I already know how high x has to go to see where they cross, because I already did the problem algebraically. But before we set x higher, let's just think a little bit about the minimums. X is the number of miles you drive. What's the lowest number of miles that would make sense in this problem? 0. You can't drive negative 10 miles. Okay, so it doesn't make sense to even bother looking in the negatives. Y is the cost. If you decided not to rent the car at all, what would you pay? Like if you didn't even call the rental car company.
0.
Yeah, you'd pay 0. Okay, you only pay money if you sign up and rent the car. Now let's set x max higher. Let's say maybe you try 100. Well, that would be better because now you see your line at 50 and you can see the cost that has the slope of 0.2. It's coming up, but it's still not there yet. What do you think a good value for x max would be? So we can see where they cross, but it's not right on the edge of the screen. Maybe a little bit in from the edge. Yep.
200?
Yeah, we could do like 200, do a little extra, just kind of round it up. Now when we hit graph, you should be able to see very clearly where they cross. There you go. Now, everyone should have a picture that looks just like that. Any question on just getting that picture? If this intersection point is not on the screen, then what I'm about to show you next won't work. So how do we see where they cross? To figure out where two things on the screen cross, you're going to press second, and then you're going to press calc. Okay, it's right the button that says trace. So press the second button and press trace. Okay, it's 7 different things in that menu. Throughout this year, we will use options 2, 3, 4, and 5. We will not talk about 6 or 7 at all. Those are for calculus. And option 1, I've just never really found a use for it. I have other ways to do option 1 that I like better. So, okay, so we're looking for where these lines cross. Which option do you think we need to pick? Yeah.
Option 5.
Option 5. So you can either press the down arrow until you get to option 5 and hit enter, or just press 5. Once you press 5, it's going to ask you 3 different questions. The first question it says on the screen is first curve. Basically, it just means the first thing on the screen that you want to use to find an intersection point. Now, there's only 2 things on the screen. So you'd think the calculator would know I want to use the blue and the red one, but it doesn't. So I need to tell the calculator which 2 lines on the screen I want to use. Put your cursor anywhere on the blue, doesn't matter where, and hit enter. You've now told the calculator use the blue line. Next, your cursor should have moved down to the red line. You can see if it's on the red line by pressing the left and right arrows and watch it move. If you have a color calculator, you'll see the font down here in the color red now. Pick a point anywhere you want on that line, and then hit enter. Okay, you've now told the calculator, use the red line, use the blue line. The last thing it says is guess. In this problem, the guess isn't important. You could hit enter right where it is and it would work just fine. If you want to move it closer to where you think they cross, you can do that, but it's totally unnecessary in this problem. So when you see guess, just hit enter. Okay. And it should say on the screen, intersection 175, just like that. So any question on getting that intersection of 175? Anyone need help with the buttons to press, anything like that? So that's something on a test that I would not help you with. So if it said, here's 2 graphs, plug them in and find where they cross, and you said, I don't remember how to do an intersection, well, that would be a specific skill we learned. So that one I wouldn't help you with. But I'll help you before the test. Okay. Any question on that? So why do you need that first curve, second curve thing and the guess thing? Well, let me show you. Okay. Just watch me type this in. You don't have to type this. Let's type in 0.5x. Okay, how many lines do I have on the screen now?
3.
I have 3. When you are doing an intersect, the calculator can use 2 at a time. So let's say that I want to find that. I need to tell the calculator to ignore the blue one and just use the black and the red. This is how you would do it. Second calc, intersect. And if I press the left and the right arrows, it shows you that I'm on the blue line. I don't want the blue line this time. I said the red and the black. If you press the up and the down arrow, it'll switch which line you're on. Okay? Now I'm on the red, now I'm on the black. Doesn't matter which one I pick first. I just need to pick the red one and I need to pick the black one. So let's let the red one be the first line I'm going to use. That's fine. The black one is the second line. And again, for this problem, the guess makes no difference at all. I could put the guess way over here. Okay, remember, I'm trying to find the one down where the red and the black cross. And if I hit enter, it still finds it. No problem. So that's an example where picking the right two graphs makes a difference depending on which intersection point you want to find. Any question on that? Okay, so what about the guess? Why does that matter? What does that do? All right, let me type in a third thing. Let me type in x squared plus 3. And let's type in y equals 6. All right, I'm going to type those two things in, and I'm going to press zoom 6. So x squared plus 3 is going to be a parabola. Y equals 6 is a horizontal line. Okay, now how many graphs do I have on the screen? Two different graphs. One's a line, one's a parabola. How many times does the line cross the parabola? Twice. This is where the guess is going to make a difference. When you're finding an intersection, it can only do one at a time. So if I do second calc intersect, first curve and second curve doesn't matter. There's only two on the screen. So pick somewhere on the blue, pick somewhere on the red, anywhere you want. Now, if I put the guess closer to the one on the left, like that, and hit enter, it gives me the intersection point for the one on the left. If I do it again, do intersect, blue, red, and now I move my guess just so it's closer to the one on the right, and hit enter. Now it gives me the intersection point on the right. This one was at positive 1.73, this one was negative. It's not always symmetrical like that. Just the picture I did. But that's where the guess makes a difference. Okay, when you have more than one, and you need to tell it which one. There's no way to do both at the same time on this calculator. All right, so any questions on intersections? That's pretty much everything you need to know. And always will ask you those three questions. First curve, second curve, yes. All right, now let's take this window and let's go like this. Y max, no, I want Y max at 10. Y min at 5. Do you think that the window I just put in is a good window? What do you think? Well, it depends what you're looking for. How about if I'm looking for a window that shows where the two graphs cross? The window's fine. How about if I'm looking for a window that shows the minimum of the parabola? No, and that's not fine. So when you are looking for a window that shows all the important features of a graph, that's called a complete graph. Okay, what is an important feature? Well, it depends on the problem. Things that could be important features would be where two things cross, where a graph crosses the x or the y-axis, that could be important. Or maybe if you had a parabola, like a minimum and a maximum, those could also be important. The way that you describe to me a complete graph is you tell me the window that you used on your calculator. So there are 4 numbers you need to write down for the window. X min, X max, Y min, Y max. Those are the 4 things that I would need to know. Now, I was going to have you find a window for a parabola, just like the one we just did, the blue one. But since we did a parabola, I'm going to switch it. I'm going to do a different one. Well, before I erase it, can you tell me, if you did a standard window, would x squared plus 10 show up in the standard window? You had a parabola that opens up.
No.
Yeah, if the vertex of the parabola is 10 units up from the origin and it opens up, standard window isn't going to show that. Okay, so let's try like x minus 1, x plus 3, x minus 7. Now, I could FOIL all that out, I just don't want to. So I'm going to type it in exactly like that. If I FOILed that all out, multiplied everything times everything, I would end up with an x cubed as my highest exponent. Might have some x squareds, might have some x's, might even have some constants. But x cubed would be the highest exponent. And we're going to learn a little bit later on that the highest exponent tells you a lot about what the graph is going to look like. Because the highest exponent in that, if I FOILed it all out, would be x to the power of 3. It tells me the graph could cross the x-axis 3 times. Compared to a parabola, a U-shape, is x to the second power. It can only cross the x-axis up to 2 times. So this could cross up to 3 times. All right, let's type it in. Let's do, if you have anything else, just go ahead and clear it. Okay, x minus 1, x plus 3, x minus 7. Type it in just like that. I'm going to start with zoom 6, and then I'll go from there. I would like to make it so I can see the terms of this graph on the screen. Okay. Can I see where the graph is making its turns on the screen? Martine, what do you think? Can I see where it's turning on the screen? No, turns are off the screen. So I could just keep guessing. I could say, oh, maybe the y min should be like negative 15, negative 20, negative 20. But I really don't want to spend all day just guessing the number. Especially, what if the number is in like negative 10,000? Well, if it goes that low, I don't want to waste time guessing. So what I'm going to do is I'm going to look at this graph. And I'm going to make a vertical line, just as kind of a tool for me to use. And I'm going to put it like about right there. So this graph comes down. I don't know exactly how low it comes down, but it's going to come down something and then go back up. What I'm trying to do is estimate the x value where it's going to be the lowest. So it's probably going to be kind of like right in the middle, all right, of those 2 blue lines. It's just the best I can do it. Where does it look like that x value is for that line? It's at about what number? Yeah.
4? Oh no, I just want to say my graph does not look like that. I typed in numbers.
And you typed in zoom 6? And you put it in just like that with the parentheses. And you used,
Oh, did you reset the zoom?
yeah, zoom 6.
Yeah, zoom 6.
It does not
No,
look like
it's
that.
not that. It's not the issue. I got through it.
Go to y equals. So it's x minus 1, x plus 3, x minus 7. That's a negative sign. I don't think that's a minus sign. You'll be able to tell the minus sign is bigger. Put the minus sign out, I'm not sure what happens. stay on down here. Yeah, for now. All right, somebody tell me again, where does it look like that x value is for that black line? Yeah, it's like about 4. So one way I could do this is I could plug in 4 here, here, and here. 4 minus 1 is 3. 4 plus 3 is 7. 4 minus 7 is negative 3. And then multiply all those numbers together that I just said and see how low it is. Or I can let the calculator do it all for me. So on the calculator, press the second button in the upper left, and then press Window. Okay, right above it, it says Table Setup. When you press second and then press Window, you should get a screen that looks like that. If your screen looks like this, we need to change it because we want the calculator to ask us for the x variable. So you just highlight the word ask and hit enter. So you should have a black box around ask for the x and auto for the y. Okay, anybody have trouble getting to that screen or making their screen look like that? Yeah.
I just lost track, sorry. How do I get to that again?
You press second and then you press Window. All right, now press second again. And this time press Graph. This is going to bring us to what's called the table. When you press second table, you might have some values already in there. If you press delete, it should delete them. If it's not deleting them, then you didn't do the previous step. That would be why.
How do you get them?
Second and then graph. What this is it's a table that allows you to pick any number you want for x. It'll plug it in and it'll tell you what you'd get for y. So let's just try one. Let's try 0. What's 0 minus 1? Negative 1. What's 0 plus 3? 3. And 0 minus 7? Negative 7. Well, negative 1 times 3 is negative 3. And what's negative 3 times negative 7? 21. So if I plug in 0, it tells me y is 21 without having to do all that out. What I want to do is check what happens when I'm around 4. I'm at negative 63. If I go 4.5, actually I got a little bit lower, negative 65. Well, now I'm going back up. Now I'm at negative 64 again. So I would say negative 65 is probably around the lowest. I'd say we'll do like negative 75, okay, to have a little extra. So we're going to set our y min to negative 75. Now let's do the same thing again over here. Just trying to get an estimate as to how high that blue section goes. What does it look like my x value is at now for that line?
Negative.
Yeah, about negative 1. So let's try it. Okay, I'm up at 32. Let's try negative 1.5. All right, it actually went down a little bit. Let's try like negative 0.8. I'm just trying numbers around negative 1. All right, so 32 is probably about as high as it goes. But what could we do for a y max that would give us a little extra?
40.
Yeah, let's do 40 for the y max. Let's put that on 40. And what did we say? I think negative 75 for the y min. So by using the table, we're not really guessing as much about what these values are. We kind of have some evidence that suggests these values are going to be fine. And I'm not going to have to keep doing this and guessing over and over and over. So type that in for your window, hit graph, and now let's see if we can see where it turns. Perfect. Good. That's a good graph. If what you were looking for is if you could see the turns. All right, so what do we write down? We're going to write down the mins and the maxes. Okay, so you can write like this. I don't think we changed the x min and max. We kept those the standard ones. Y min, negative 75. Y max was it 40? Yeah. Okay, so you can write it that way. Or, if you don't want to write down x min, x max, those words, you can write it like this. That's exactly the same thing. The first two numbers that you give me are always for the x's, and it's minimum, comma, maximum. Has to be in that order, minimum, maximum. The second two numbers you give me are for the y's, and it has to be in that order, minimum, maximum. So if you saw something on the test and it said, set your calculator to a window of, and it wrote that down, it means to do this. So that's how you write your graph, or your window. Any questions on that? Okay, so the original problem I did was a parabola. When I changed it, it was no longer a parabola, so not a parabola. All right, try one more, see if we can get a good window. Let's just type in square root of x plus 20. If you're not sure where square root is, you press the second button, and then it's the fifth one down on the left. Now, square roots are one you need to be a little bit careful about. What I just circled has to be a certain number or higher. If it's not, you're going to end up with an imaginary answer. What kind of numbers are you allowed to take the square root of and get a real answer? Yeah?
Numbers above 1.
So you could take, let's try a
Above
number.
0, I'd say.
If you took the square root of, let's say, like 0.6, that would work out okay. You get 0.77. So that's below 1. So you can take the square root.
Above 0.
What is it?
Above 0.
And including 0. Yeah. You can't divide by 0, but you can take the square root of 0, no problem, and you get 0. So whatever you put underneath here always has to come out greater than or equal to 0. So think about that in this problem. You need x plus 20 to always come out greater than or equal to 0, no matter what you plug in for x. So that means you couldn't plug in negative 100 for x. That'd be too small. How could I get x by itself there so I know what I can plug in? Yeah?
Minus 20.
Yeah, just minus 20 from both sides. That tells you your x minimum right there. X has to be a number that's negative 20 or higher. If you go lower than negative 20, you're going to get an error. You're going to get an imaginary answer. All right, so let's graph that. I think I already typed it in. Let's just set our window. You can go a little past negative 20 if you want. The graph won't go that way. But if you want a little extra, you'll be able to see it. Let's set the x max up to, I don't know, let's go up to 100. Now, if you filled in 100 for x, what's 100 plus 20? 120. And the square root of 120 is pretty close to what number? Yeah, if it was 121, it would be 11. It's 120, so it's probably like 10.9 something. All right. So as far as a y max in this case, I don't need to go anywhere near 40. We only need to go to 11. So, go a little extra. Let's go 14. You do 15. Y min, well, negative 75, that's pretty low. We don't need to go that low. Let's just put it on the standard one, negative 10. Now, we'll take graph and see what it looks like. And that's what a square root function always looks like. It has a starting point, and it curves in one direction. A square root function is basically half of a parabola on its side. That's exactly what a square root function is. It's half of a parabola on its side. Now, you might say, well, it goes off the screen. Well, yeah, it's going to go off the screen. It's going to keep going forever. Right. If you put that there, this part is just going to keep going. You're never going to see it do anything else. Just goes like that. All right, so complete graph, I would write down those numbers right there. That was a negative 25. X min max, Y min max. Not the only answer. You definitely could have other answers to that, but I would say those numbers do work pretty good. All right, any questions on that? So finding a window, it's more of an art than an exact science of how to do it. It takes a little practice. Okay, so homework from this section is pretty light, 6 to 10, 18, and 29. Normally, you'd probably have double, more than that for homework. But for tonight, it's only those 7 questions. Reminder too, I will be after school today because we have the back to school night tomorrow. So my extra help day is today. Okay. First test will be on Friday, and it will cover sections 1.1, 1.2, so we've done up to that. And the last thing we're going to do tomorrow, 1.3, part 1.